So, hey, the goal here is just to show you a few more examples of finding inverses of logarithms and exponentials. And in each case, the process is the same. So, a couple of notes. Note one. Several students have asked, well, how do you know whether the plus 3 is supposed to be in with the log or whether it's separate from the log? The answer is parentheses. If the plus 3 is supposed to be in the log, there will be parentheses around it already. If there are no parentheses, then that means just what comes right after the word log here is what's inside the log. So let's see. We'll see how that works here in a little bit. Here's your general process. Just like with finding any inverse, the first thing you do is you switch the letter x and the letter y. Everything else stays the same. Then your goal is to get the exponential or the log by itself, meaning if there's any multiplication or division, or if there's any addition or subtraction, those need to be dealt with first. In this case, there isn't. There's some addition, but it's inside the logarithm, so we're going to save it for later. Next then, you're ready to now switch from the log form to the exponential form. My goal is to get at this y. It's currently in a log prison. To deal with the y plus 3, I've got to get it out of the log prison. The way to do that is with exponentiation. So 3 to the power of x equals y plus 3. So from the log form to the exponential form. At this point then, to get y by itself, subtract your 3 on both sides. And you're all finished. There you go. That's your inverse. Let's go again. Here we have an exponential. So to find the inverse, first thing, switch your x and your y. My goal is to get that y now by itself. To do that, I've got to get the exponential isolated, meaning I want 3 to the power of y to be by itself on one side of the equal sign. So do a subtraction of 5. And now you're ready to switch to your log form. So y equals log base 3 of x minus 5. Now, don't write it like this. I need the whole x minus 5 to be in the log. That means you need parentheses. Without the parentheses, it means just the x is inside the log, and the minus 5 is separate. So we're going to do this to show that the whole x minus 5 quantity should be inside that logarithm. Okay, let's go again. This is fun. Take your x and your y and you switch them because we're finding an inverse. 5 to the y minus 2 to the 1/3. This one's a little more complicated, but the process is the same. I need to get this 5 to the y by itself so I can switch to log form. So currently I got to get rid of this 1/3 power, raise both sides to the power of 3. 5 to the y minus 2. Add the 2 over. And now, only at this point, when that that exponential rather, is by itself, are you ready to switch to your log form? So y equals log base 5 of, in parentheses, x to the 3rd plus 2. Okay, next up. Notice this time, you see how the plus 5 is separate? It's not in the parentheses with the minus 4x. That means you've got to, in order to isolate the log, move that 5 over before you do the transition to the exponential form. So here we go. Let's switch x and y. Before we switch forms, we got to subtract that 5 over. Okay, we are now ready. Because the log is by itself, no other plus, minus, multiply, or divide on the front or on the back. Ready to switch to exponential form. So 4 to the power of x minus 5 equals negative 4y. And then to finish, divide both sides by negative 4. And so here we go. Y equals negative 4 to the x minus 5 over 4. That's not the only way to write this, but we won't get into the algebraic tricks you can use to simplify that. We'll just leave that as it is for now. Okay, here, you know the drill. Give it a quick pause. Unpause when you're ready to check things. So switch your x and your y. This one's got lots of good stuff to it. So 2 to the power of y plus 7 over 4 to the 1/3 power. We've got to get this exponential by itself. So first, raise both sides to the power of 3. I don't think I left myself enough space there. 2 to the y plus 7 over 4. Next, let's get rid of that divide by 4. So multiply by 4 both sides. So 4x to the 3rd. Next, subtract the 7. Now and only now, once this exponential is by itself, do you switch to your log form. So y equals log base 2 of 4x to the 3rd minus 7, and you slap that in parentheses. This whole thing needs to be what goes inside the logarithm. So easy, no? Doable, yes. And a student in one of my classes pointed out, hey, a great way to check this is you graph the original on your Desmos, you graph this, and make sure they're reflections across that diagonal y equals x line. That way you can be sure they're inverses. Okay, one more for the road. Let's find the inverse here. Switch your x and your y. Now the x minus 7, that's in parentheses, so that's all inside the log. But this minus 8 on the back, that is outside the log. You got to deal with that first. Add the 8 over. Log base 5, x minus 7. Divide this 8 away. Now the log is by itself. No more plus and minus on the back, no more multiply in the front. You're ready to switch to your exponential form. So 5 to the power of x plus 8 over 8 equals x minus 7. Oh, you know what? I've been writing x's both times, haven't I? I'm sure that was making you super mad. This, of course, is supposed to be the letter y, as are these supposed to be the letter y. I got a little too excited. And that means this one down here also a y. Okay, then, let's finish up. Add the 7 over. So y equals 5 to the power x plus 8 over 8 with a plus 7 on the end. So I want to go back to the very first page here. So the process, even though it got a little bit complicated with some extra steps, was always the same. Switch your letters x and y. Isolate the exponential or the log, depending which form you have. Switch to the other form so that you can then get the y by itself.